Okay, today's lesson, we're continuing with the idea of using Venn diagrams to represent sets. Remember that most of these can be replaced by tables, but the key thing is today is that we are looking at what if there are three events. So last lot of Venn diagrams, there were only two. So what if there are three? Then obviously you need to get three circles. Basically, a lot of the concepts are exactly the same. So yesterday we had 4 regions. Today, what we've got is 8 regions with the with the 3 circles. So the key thing we need to be aware of is that there's 8 regions. So set A is 1, 2, 5, and 4. So that's 1, 2, 5, 4. That's all of A. B is made up of 2, 5, 6, and 3. And good old C is made up of 4, 5, 6, 7. So you can see that there are there's some more overlaps, but also there's 5 which actually includes all 3. So the example I gave for you to think about these things is thinking about what classes you're in. So if we add science to our event, so you're either in maths, English, science. So this area here would represent people who do maths but not science and English. Obviously 5 would be the one that you do all 3, and then lastly 8 is the area where you don't do any. Yeah. Okay, so I'm going to talk about that. You can see 4 and 5 are the overlap or the intersection of A and C, and 2 and 5 is the intersection of A and B, and 5 and 6 is the intersection of C. So what does that mean for the different things we want to be able to do and regions we want to represent? Is that the rules are exactly the same as last time. If it's a union, okay, that means or, so that's it. You include everything. Okay, when it's an intersection, it's only the regions that are in common. Okay, that should be the thing that you always fall back on. So when we look at this example here, the first thing we want to do is do the brackets first. So we want to look at what is B and C, or what is the intersection of B and C. Well, we know already that the intersection of B and C would be 5 and 6. And then we look outside the brackets. What is A? A is 1, 2, 4, and 5. So because we have a union, we include everything. So it can be represented by all of these numbers. 1, 2, 4, 5, and 6. 1, 2, 4, 5, and 6. So we end up shading in these areas. All right, and nothing else is shaded in. So it's the exact same as yesterday. So here's another example. This is saying not A's intersection with B and C. Same thing again. Find out what B and C is, 5 and 6. We know not A is everything that's not an A. So it's not 1, 2, 4, or 5, it's everything else. And because it's an intersection, it's going to be the ones they have in common, which in this case, it's only 6 that is in both lists. If that was a union, you would have to include them all. So we shaded this area to represent not A, intersection, and B and C. Again, same process as before, slightly more difficult because we need to work out what represents B, the intersection of B and not C. So not C we know is, or the complement of C, is 1, 2, 3, and 8. Now, B we know is 2, 3, 5, and 6. So because we're looking at the union of each one, it's the ones that, the intersection of B and C. So the ones that are common, so we've got 2, 3, 2, 3. The rest we get rid of. So B and C is equal, B and the complement of C is 2 and 3. Now we know not A from the previous one is 3, 6, 7, but because it's the union, it's everything. So it's 2, 3, 2, 3, 6, 7, 8. So we shade in everything but 1, 4, and 5. Okay, and so that's basically it. You may have to go back and go through that video a number of times, but it's exactly the same process as before. There's just more regions and more things to look at. So the other thing that it's sometimes asked to do is describing the shaded region. So let's take a look at these. So an easy way to think about it is to number all the sections. And if we quickly look, that 2, 5, 6, and 3, that's B. So this must be the probability of B. Okay, this one again, number all the sections, 1, 2, 3, 4, 5, 6, 7, 8, is that we've got 4 and 5. So that's quite easy to see that that's the complement, sorry, not the complement, the intersection of A and C. Right, this one gets a little bit more tricky. So we've got 1, 2, 3, 4, 5, 6, 7, and 8. If we take a look at this here, from that region there would represent the intersection of A and B. The other thing we can look at is that is all of C. So then the choice is, do we use intersection or union? So union is the one where it's the ones in common. So we use the, some habits with use are hard to stop. So it's the union of C and A and B. This one's relatively straightforward. This region here would be the probability that you've got of B and C. So that must be not B, C. This one, we've got obviously that represents A and C, but the bit that's missing, bit that's part in C, but not part of B. So it would be A and C and not B. So again, not A or B or C. This one's relatively easy. So it's B, A or B or C. So those, you do need to practice those. So there's some questions in your book to go through. But the key thing when it comes to exams is that you tend to look at questions like this, and this is the type of question you might be given. And they're exactly the same as the ones with the Venn diagrams, but you do need to sort of, it's a bit like a Sudoku really. You've just got to look at the information you've got and then start eliminating and filling in the diagram until you get your answer. So 150 people go to a Van Halen concert and were asked if they knew how to play the piano, drums or guitar. 18 people played none of these. So I can put it out there. The other thing that's helpful sometimes is making sure that I know the total, which is 150. So all the numbers in the diagram should add up to 150. So I've used that one, so cross it off. And you don't have to do them in order, but sometimes it's just as easy. So 10 people could play all three instruments. So that's here. So put 10 in there. 77 people could play the drums or guitar, but could not play the piano. So what that means is I need to label the different outcomes. So 77 people could play the drums or the guitar, but not play the piano. So I'm going to come back to that one. 73 people could play the guitar. Okay, 13 people could play the piano and the guitar, but could not play the drums. So what that means is that that must add up to 13. So I can put a 3 there. The last one, 21 people could play the piano and drums. So that must mean that one equals 11 because both of those should add up to 21. That makes the next one a little bit easier. So at least 49 people could play at least 2 instruments. So you've got to be careful with questions like that, because if that wasn't at least, it was exactly 2, you wouldn't have to include the one in the middle. So we have to make sure that this value here is the one that makes it add up to 49, which means this one must be 15. So that leaves us with 2 clues left. So we know that 73 people could play the guitar. So that circle should add up to 73, which means 20, 27. And then from the total, we know that that should all add up to 150, so we get 21. So that's how you work through the answer. Um, I've got another example here for you to have a go at. So there's 100 people were asked if they knew who any of the following are: Loki, Hermes, and Ra. 25 people didn't know any of these. 3 people knew all three. 48 people knew who Hermes or Ra were, and so on and so on. So draw your 3 circles, have a go at it, and then the answers are to follow. Okay, so there are the answers. You can obviously go through the exact same process. These actual examples were taken off a website that generates different um, questions for you. I'll include them in the lesson for you to have a go at, mainly because they also come with video solutions, so you can follow those as well. Really important you're able to put these together, because obviously if we know where each one is and we know the total, we can use them to convert and look at probabilities.